Hello, Precalc class. This is Mr. Blackwell here. I'm sorry I can't be with you today, but hopefully this will help you get started some on your assignments for the day. So today we're doing lesson 5.2.4, and kind of the main objective here is kind of looking at logarithmic graphs. So we've been studying logarithmic functions, and so we want to kind of now look at what do the graphs look like. We have touched base on some on how they are inverses of exponents, so you may have a good idea already what they may look like, but the core problems that we'll be focusing on at 93 to 95, and also it'd be nice to do a little bit of the learning log and problem 97. So as I said, this lesson investigates graphs of y equals log bx. And since f of x equals log of x as a parent function, it is important that you can visualize and transform its graphs as well as sketch graphs in different bases. So in other words, right, whenever we deal with a parent function, we always are ending up with something that allows us to do some transformations. So in our case, right, so if we were wanting to write kind of graphing form, this might be jumping a little ahead, but if we wanted to have our graphing equation, we would have y equals a times log base b of x minus h plus k, where when x is equal to h, that is our vertical asymptote. Okay, so it's our vertical asymptote. Right, so when we're done with our exponential, right, it's the k that's an horizontal asymptote. But now, because this is an inverse, the h is our vertical asymptote. And so hopefully that helps you to start to visualize kind of what's going on. So 93 asks some pretty basic questions to get us kicked off. Just want us to write our equivalent exponential equation for y equals log of x. That shouldn't take long. And, b is, well, how logs and exponents related. So write the inverse of y equals 10 to the x. Both of those I wouldn't imagine taking more than 30 seconds. Now part C, so at this point you may want to grab some graphing paper. It does want you to make a sketch of the graph y equals 10 to the x. It also wants you to state the domain and range. So what is going to be your domain? What is going to be your range? For y equals 10 to the x. Now once you have that done, you can move to part D and use that table and graph that you have just made to graph y is equal to log to the x. And now once you have that, what is the domain and range here? And that should be pretty straightforward, because, right, these are inverses of each other, so you can ask yourselves, what does our domain and range do with inverses? And then we can explain to Segura a strategy she can use to graph y equals log of x. And then f of x equals log of x is a parent function, and it asks us what is the locator point. So you could think about what does it mean to have a locator point, and see if that can help you out answering part F. I imagine the F might make you think probably the hardest out of those, although C, D, and E may take a little longer because it's more work, but probably not more difficult. So 94 now wants you to just graph a couple of these equations. So you can use what the work you just did in 93, and using that work in 93, you can hopefully do some transformations here to help you do this. Right, so 94, so let's pay attention to what it's asking. It's asking us to graph each function on the same set of axes as we did in our problem from 94, or in that problem from 93, right? So all this should be in one graph on the same set of axes, and then you can compare these three different equations, and then ask, for x is greater than 1, how does log of a of x compare to log of b of x? B is greater than a. So in other words, as your base increases, what's going on with your graph? What's happening? What's do you see any type of trend that might be happening there? And then 95, it just wants you to play around a bunch with different transformations. As I showed earlier, we had those different transformations. We have a parent function, then a transformation, and so now this is just showing different transformations and how all these different transformations affect different things. So once again, graph each of the following transformations of y equals log of x. These ones I would say do on a separate graph, but as you do this, right, it's going to have you describe the transformation, state the domain, range, and what is the locator point. So now if you're still trying to wonder what is the locator point, maybe a little help, a little thought on this. I'll talk about the locator point for the exponential, and maybe you can help as you think about that. You can think about what does that mean for a logarithm. A locator point, when we typically talking about exponentials, is going to be where at 0, 1. Okay, so in other words, it's where kind of that 10 to the x crosses the y-axis. So that is our locator point for exponential. So you can think about that as you think about the locator point for logarithmic functions. And then now that we have those, let's look at some of the things that can affect our graph, our logarithmic graph. So we got A, and we have H, and we have K, and we also have B. And so what I'm going to do here is I'm just going to pull up a random organizer, and we will get a couple numbers. So 2, 6, 2, and 5. Okay, so 2, 6, 2, and 5. So what I'd like you to do now is, using these numbers, plug them into a log function now that you've done now that you're done with 95. And after you plug these in with graph them, and just kind of similarly look at how does, and talk about really what is the A doing to your graph? What is the B doing to your graph? What is the H doing? What is the K doing? How do these affect your graph? And so, in essence, so problem 97, I want you to really talk about how A, B, H, and K affect your graph individually. So in other words, how do all of these different things change what you're doing? Right here we're given some set numbers, but talk about A. How did A affect what your graph looked like? How did B affect what your graph looked like? How did H affect your graph? Was it transformation? Was it a dilation? How about K? What happened there? Was it a transformation, dilation, rotation, reflection? Talk about how it transformed your graph. And hopefully that will get you started for the day and get you going throughout the day. And I look forward to seeing you guys tomorrow. Have a great day. Bye.